Hello and good morning, everybody. Sorry for the delay. My name is Jeff Mannion, and I am the program director here at Standard Imaging, but I also wear another hat, and that is of the product manager for StructureIQA. And again, I want to welcome you to this session to tell you about an exciting product that we have that I think you'll all, find a lot of value in. So StructureIQA is the first quality assurance software for auto-segmentation contouring engines. And so, for example, it's a fast, intuitive application that allows users to objectively compare anatomical contours generated by sophisticated algorithms or by humans to a set of library standards that you have available to you. It provides comprehensive comparison metrics that are both sensitive and specific. We have this new feature, it's called batch analysis, that you can calculate hundreds of data sets and thousands of structures in just minutes. And and through the UI, you can drill down and to investigate failing cases both visually and objectively. And of course, the software can produce all kinds of formal reports and that sort of thing. And so that's a nice kind of takeaway from that. So let me just, before we kind of dive into the software here, let's just take a look, talk just a little bit about where this thing is coming from. So when AI-based auto-segmentation first emerged on the market, I don't know, about 10 years ago or so, it wasn't all that great. Physicists were hesitant to adopt it. Well, since that time, that's all changed now, and it's rapidly being adopted across the industry. So now, physicists and physicians who are adopting, this new technology really need to say to themselves, "Hey, I need to do acceptance testing on this thing." How do I know it's the auto contouring engine is changed at all, or there was an update, or any of that sort of thing? And that's why Structure is important to you right now. You should use it before you decide to buy an auto-seg engine. Ideally, when you're checking out auto-seg engines, you want to get, let's say, a temporary license from your vendor and to try out the software. StructureIQA would be the perfect tool to organize and produce objective evidence that it is like, for example, is the Electa model working the best, or is it the Varian, or is it any other third-party company that's popping up, or across the industry? And some of them are doing really great work, like Limbus AI, or there's like another half dozen or so auto-seg companies that are emerging it. Again, use it before you buy to make good decisions. Do I go with the Variant? Do I go with the Electa, or so on? And then once you buy it, use it for commissioning or acceptance testing. Use it clinically. So you say, hey, I've decided on an auto-seg engine. So now let's figure out where we trust it and where we don't. Do we like certain organs of the model that it's doing, or but don't trust others? The user is going to have to make those decisions all along the way. It's extremely inefficient to ask them to look at the results and say, hey, do I like them or not? Hey, does that look, thumbs up, thumbs down? No, that's not scientific. And it doesn't lend its well to automation, and it's very inefficient. And of course, it's subjective. So with Structure, you'll get comprehensive analysis and metrics that you can depend on to make, to do that commissioning work. So use it before you buy it, and use it before doing acceptance testing. And then, of course, the third reason to buy it is that you're continually, there'll be new models coming up all the time for these auto-seg engines. It's going to be auto-seg engines are going to be a lot like DOS engines, with updates, constant updates, but probably a lot more rapidly. They're going to be continually, updating and releasing. So hey, let's say the model 2.5, now includes a small bowel. it could, or so it could be an existing model that has more organs, or it may be a new model at a new body site, or a model that supports, let's say, a new imaging modality. Hey, we have a head and a neck for the CT. We just released the MR for the brain. As with any new release, you want to check to see if the software, the update broke anything, and so you'd use it for regression testing. Hey, it used to do head and neck really great, but now with this update, yeah, I got this new, image modality, but now it's kind of screwed up my results, for head and neck. What happened here? That kind of a thing. So again, so why should you use StructSure? You use it to help decide, which auto segment engine you'd like to buy. Number two, you use it for acceptance testing, and then also you use it whenever the vendor rolls out a new update or a change or anything like that. So let's take a second here and let's dive into the software. Let me see if I can bring this up. Hang on 1 second here. There, oops. Boy, 1 moment here. Sorry for the delay. There we are. There, everybody should see that. And so here it is. It's a simple application, by the way. It's a Win32 desktop application, easy to install, no fuss, no muss. You don't have to worry about databases and the whole 9 yards. It's super quick. And so being able to install it, especially if you've got a pretty stringent IT department, not going to be a big deal. So let's get started here. So at the very top here, of course, we're going to load data, of course. And so the very first thing we want to do in here is the load data interface. And you say, hey, I want to take a look at the CT set. So before I get started here, so what we're going to do here is we're going to compare, our gold set of let's say of a CT scan and structure set. Let's say we have this one set that we always look to is really, really good. And so then we did the same thing, the same set of images and all of that with let's say an auto contouring engine, okay? Or even just a human. Somebody is training and they want to try to get good at this, and so that would be our secondary file. So the primary structure set is the gold set. The secondary file would be the one we're going to compare against. This is either done by an auto-seg engine or by a human being. So first thing you want to do is we'll open this up and we'll grab some CT images. And so we grab that and it's loading them. I want to apologize here offhand. This will be a little bit slow. I'm doing this from a different computer. It's not quite, it's a kind of an older one. And so it doesn't have the horsepower that the one that I usually demo this on. So, but anyway, there it is. And so you can see that it brought it in and it gives you a little bit of some metadata there. And so here we select our primary structure set. And again, this would be our gold set of data. So we bring that in and it says here's what I found right here. And here are all the anatomical areas of regions of interest that it found by scanning through this the structure set. And then finally here we'll say, okay, I want to compare it against this set here that was done by an auto-seg engine. And again, it'll do the same things as here. I found all of these things. And by the way, here's the matches that I found between this group and that group, between my auto-seg engine and my gold standards, and here they all are right here. So I go, okay, well, let's go ahead and load the data and see what we got. So we load it up, and so now we have our interface right here, and up on the upper top, there's kind of this navigation, upper left, we have this navigation plane, so we can kind of see it from, let's say, the 10,000 foot level. We can see all the areas that this set includes. Down below, again, here are the regions of interest that was found common between the two sets right here. Okay, there that is. And if we want, we can turn them on or off. And then on the right-hand side, here is the CT settings. You can see I can kind of roll through it. And then you can see where the regions of interest are outlined here. So, and on the left-hand side up here, we'll have like a legend. So if I, let's say, move up to maybe an interesting area here, it's kind of fun to, yeah, like for example, this one right here. So, here in the green, we have the left parotid, and then right here in this sort of pumpkin orangey type color, we've got the right parotid, and here are all the structures that are available to us, overlaid over the CT images. Up here on the upper right hand side, we've got another key here, a solid line. That's our primary set. If you remember, that's our gold set. And then the dashed line represents the secondary set, or in this particular case, from an auto-seg engine. So you can kind of see the differences here, maybe right here. But here, let's do we're going to do a calculation now. Oh, before I go further, here's an image adjustment. This is basically just a window leveling, so we can change all that, and some nice little tools that way. Okay, so anyway, so let's do the calculation. We are now going to calculate, the differences between the gold standard and the secondary, or the auto-seg, what it came about with. So it's doing all the comparisons, running through the calculations, and so now we've got some extra things to look at. Just from a visual standpoint here, we can see here, actually what I can do, we have a nice little tool here. We can increase the opacity here, so I can see a little, there we go. So in this particular example, you'll see here in the green, this is where the two sets agree, okay? And that's real easy to see there. But then, actually, maybe I can find them. Maybe a slightly, here we go. Here's a slightly better example. And then, so the green is where they agree. The blue here means that the primary set, or our gold standard, showed the area of interest to go way out here as well, where the secondary one missed it. It said, no, I didn't see anything here. I didn't see anything at all. And so, meaning it's missed it, okay? And then here we can see some red. And that's where the auto-seg engine actually overshot, okay, against as compared to our gold set of data here. And so we can, again, it gives a nice little visual right here. So right here, it's very interesting on the medulla oblongata that we undershot at the top here, and then we overshot kind of on the left side. But again, that's just a nice little visual representation. Let's take a look at some of the actual analytics here. So again, on the left-hand side here, there's that list of regions of interest that both sets had common. And again, it's basically the same list you see on the left here, okay? And then let's move across the top here of all the different metrics. First of all, we have volume 1. That's the volume of, this is how much volume in cubic centimeters that was found in our gold set of data. And then here in our auto-seg data. And then here's what's common between them. Again, here's what's missing. Again, when we saw that a moment ago, right here with this kind of blue shaded area. Here's how much is missing in cubic centimeters. Here was extra in this particular case for the CTV1. There was nothing, so it hit it right on. And of course, then we also provide a dice coefficient, and then we also offer a max difference. And so that max difference is, how much different, is it from the center here to going further out in millimeters? Is it in this particular case? It's dead on, so it's awesome. So, but here, let's go to one here that's maybe not so great here. Here we go. So this one really missed, and you can see here that in this histogram, we can see that, there were, 0.07 millimeters away from the most common area was, we had that much of an overlay, or extra, if you will, in the red or blue we missed. And as you can see, it gets further, the further out you get, you can still see that, yeah, we still had, at 0.08, we had 0.08 at roughly 3 millimeters, and then at 4 millimeters, it was still at 0.08 over radiated or over compensated for, and then finally here it was went down to 2. So again, we got some really nice metrics right here. And you can see, you can flip through them all as you can kind of go through them. Very handy software that way. And you can see, of course, you want to get to where this is the most common area, that green. Again, blue is where the auto-seg missed. Red is where it overshot, if you will. And you can tell you by how many millimeters out. And then on the right-hand side, we got some, again, some nice little metrics in, more of a tabular form where, again, the name of the, the name of the region of interest and all of those types of things. And then we actually break it down by, each of the slices here and give it all the, all the scores here, so you can see all of the things that, that made up this chart. So all kinds of great metrics on that end of it. Going back maybe a little bit here into preferences, we can see, like, for example, I can kind of tune, if you will, my voxel resolution in terms of millimeters, like how tight do I want to, score this, or how tight do I want to have it so that, if it's, off by point, like 1 millimeter, do I then say, hey, I need to, I'll score it that way, or do I, or the difference view in opacity also as well. And also we can also type in here, regions of interest to ignore. So that's a handy little thing to have. Metrics. So over here on our left-hand side, you can see, about just below the calculate button here, when we do all the calculations, we can, define how we want to score, how you want to score your metrics. Okay, out of the box, it comes off with this default linear, and you can kind of see it right here. Okay, again, from here's your center line, and then millimeters away. And you can change the upper distance threshold. You can change any of these different metrics up here. It'll change the curve then. So for example, you can do several of them here, and then what you can do is you can then apply those metrics, over here on your left-hand side. So here, let me just close that real quick. So if, hey, I'm going to try a different metric on it, so I will, use scenario 100 or something like that, and then do the calculation. So again, very customizable. You can come up with your own type of scoring, if you will, and whatever suits your needs. And then you could also put together some rules, and I don't have any here right now, but you can say, hey, in some, in DICOM files, the way that, either human beings or, the auto-seg engine names things may be different from one to the next to the next. Or, we call, the left parotid, in our gold standard, we have a certain name for it. And so we say, well, yeah, we also call it, something else in our auto-seg engine, even though they're really the same thing. So what you can do here is do a compare. You can basically map that. You can say, when I see L parotid, it also means left parotid, or etc. So you can just keep doing that. That way you can put together a nice mapping so that, say, hey, why did it miss the left optic nerve? Well, they call it L_optic_nerve. And oh, okay, well here, let me type that in, and that way I can, use that mapping, and now it'll pick it up. Okay. Let's see here. Again, these are just some handy little menu items to show the panes and things like that. So it's really pretty straightforward. We also offer some really nice reporting features. Full report, if you want, that can take a few minutes to put, or a few moments to put together, but they all come in a PDF. We could do it just a simple one-page report. That's what it kind of looks like there. So all kinds of great stuff that you can do. Oh, the last thing I want to mention to you all here, let me just see if I can't do this real quick. There we go. Right, we already know this. And so again, number 1, 2, and 3, why would you buy it? You buy it for evaluating an auto-seg engine for purchase, acceptance testing, and vendor updates. But what we have here, here's the output of a batch file. So basically, what you would do is by not using the user interface so much, but there's a way to do it through the main file system. Here, let me see if I can bring that up for you real quick. Yeah, so right here you would go to File, and then you go Batch Analysis. And basically what you would do is you'd look for, you'd have a text delimited file here, and you would then bring that in, and in it, and here we go, and in it you would have, excuse me, here's the path, for example, for the reference scan. That's your gold standard. Here's the one you want to compare it to, the region of interest name, etc. So you could just do, hundreds of these things. Didn't mean to do that. Hundreds of these things that you could just quickly make your way through. So, sorry about that. I kind of hit the wrong thing there. So anyway, and so that only takes just a few minutes to do, moments really. Once you have all your stuff in a CSV file, basically where's the paths to all of this information, both the gold standard information and the the stuff that you want to compare it to, auto-seg or a human, then it'll just rip through all of that and give you all that in a spreadsheet. So it really just, it takes moments. So that concludes my webinar for today on StructureIQA. And again, 3 reasons. 1, when you're trying to evaluate buying an auto-seg engine, it gives you, again, great metrics. Number 2, when you're doing your commissioning. And number 3, when you have updates that come, for your auto-seg engines, just to see if anything changed. If you have any questions, please, feel free to contact me. My name is Jeff Mannion. That's jmannion@standardimaging.com, or reach out to your sales rep, or just use the standard sales.standardimaging.com, and we'll be glad to answer any questions that you may have. I hope you all have a great rest of your day, and thank you so much for your time.